So in previous classes, we have completed the Ohm's law, which was the statement of Ohm's law was the electric potential or the electric current is directly proportional to the applied electric potential, and hence we can write V is directly proportional to I. Whenever proportionality sign is removed, some constant comes. This constant is called proportionality constant, and we got to know that this proportionality constant is act or behaves as the resistance of the conductor. Whatever conductor through which the electricity would be passed, it will be behaving the resistance for it. Resistance means kind of barrier in the flow of electric current. So, and what it is actually, it is the proportionality constant. Whenever this proportionality sign is removed, some constant comes. This constant is known as R, and R works as resistance, means barrier in the flow of electric current. More the resistance, less flow of electric current. All right. And we got to know, since it is the proportionality constant, that's why the value of R, by this formula we can achieve R is equals to V upon I, and since it is the constant, so value of V upon I, that means the ratio of electric potential to the electric current always remains constant, whatever be the or we can say as whatever changes would be there in terms of electric potential, in the same manner electric current will also change. If you increase the electric potentials, in the same manner electric current passing through the electric circuit should increase, and if we will be decreasing the electric current or electric potential, then in the same manner electric current should also decrease in such a way that R value should always remain constant. All these things we have already done in the previous class. So let's discuss today the graph between V and I, VI graphs, and graphs related to Ohm's law. So what is the basic concept here? Learn this. Whenever this kind of relation is there, Y is directly proportional to X, then always the graph will come a straight line in such a way, means kind of an oblique line. This oblique line has given the name straight line, just like you are having some name, I am having my name Hanu. So in that way, this graph has given the name straight line. So this straight line always comes whenever this kind of simple relation is given. This is called the direct relation. Y is directly depending on X, or we can say Y is directly proportional to X. So the graph between X and Y axis, whatever quantity would be written on the corresponding axis, then the graph should be the straight line if there is a direct relation. Similarly, if there is inverse relation, this kind of format is called inverse relation, means 1 upon something is there. So as this quantity will increase, this quantity should decrease. Here, if this quantity increase, this quantity will also increase. If this quantity decrease, this quantity will also decrease. But hence, this is the direct relation. This is the inverse relation, means what? If this quantity, denominator quantity will increase, so obviously this quantity will be decreasing. It increases, it will decrease. It decreases, it will increase. Got it? That's why it is called as inverse relation, and hence the graph, whenever this kind of relation you will be observing, always the graph will be hyperbola. What is the name of this graph? Hyperbola, hyperbolic curve. So name of the graph is hyperbola. Kya bola? Hyperbola or hyperbolic curve. Got it? Now let's discuss here. This is the basic concept behind the graph. Means you should learn directly how it comes. You will be getting these things in grade 11 and 12 in maths if you will be opting the science. All right. Now let's discuss what could be the relations or what could be the graphs possible which are related to Ohm's law. So since by Ohm's law we have Ohm's law, V is equals to IR, and this relation came when V is directly proportional to I. So this is following exactly the same relation, where if I'll substitute the electric potential on Y axis, it means Y axis is serving or is mentioned by electric potential. And similarly, if on x-axis we will be representing, or x-axis is represented by current, electric current in ampere. This is in volt. Then the graph between V and I will be a straight line. So whenever you will be asked, draw the graph between V and I. Similarly, if I will be asking what should be if the I versus V graph, so we also know that V is directly proportional to I is also directly proportional to V. Again, I versus V graph by nature means how it will look like. This will look like again the straight line only, because it is also the direct relation. Y directly proportional to X. So this is I, this is V. But there are something which would be changed, that is called slope, right? Now, what is slope? Although it's not related to your grade, but still, let's learn. Slope means, in simple language, I'm telling you, slope. Whenever the word comes slope means y-axis quantity upon x-axis quantity. Done. Y-axis quantity upon x-axis quantity. And just check it out. What the is there any new physical quantity can be found by taking this thing, y-axis quantity upon x-axis quantity? If there would be some new physical quantity, then slope will be represented or representing that physical quantity. If it is not forming any new physical quantity, then let it be. For example, if I'll substitute the slope of VI graph, how do we read it? VI graph. How do we read? Whatever physical quantity is written on y-axis, first we write here. Then whatever is written on x-axis, then we write here. So this is called VI graph. And here, this is called which graph? IV graph. IV graph. So what we are going to find? Slope of VI graph. Slope of VI graph means y-axis quantity upon x-axis quantity. On y-axis, which thing is written? Which physical quantity is given? V. On x-axis quantity, which physical quantity is written? I. So I'll be writing here I. V upon I. Do we have any physical quantity which is represented by V upon I? Yes or no?
Yes, sir.
What is there? Resistance.
R.
V upon I is R. So what we can write? R. Hence, by this first graph, we are getting one information, that the slope of, what do you understand by the slope? It is just like a ramp at your home through which you take your vehicle in your house, or you just, or similar kind of slope in the park where the children enjoy their games and also that kind of slope. Slope means something which is inclined from the ground. This is the ground flat, and something which is inclination. This is called a slope. So that's how this angle is called slope. So what the slope will be representing? Slope will always represent y-axis quantity upon x-axis quantity. And here for VI graph, slope of VI graph will be representing resistance. And whenever there is a slope is a straight line, or learn another concept. Although all these things we will be learning in grade 11, 12, learn here only. Slope, if slope is a straight line, if slope is a straight line, then slope straight line, then the slope is given or represent uniform slope. And slope for VI graph is representing this thing, resistance. So uniform resistance. Uniform means similar, same, constant resistance. That means the VI graph should show always constant resistance if the graph is a straight line. Got it? Is that clear? Yes or no? Quickly tell me.
Yes, sir.
Very good. Similarly, this is IV graph. IV graph, since this is the direct relation, that's why the nature or the graph should also look like the straight line graph. And whenever graph is a straight line, its slope should be, if slope is a straight line, its slope should be uniform. So whenever I'll be saying the straight line, it means it should show uniform slope. But which slope? This is representing uniform slope of IV graph, not VI graph. And what is slope of IV graph? So slope of IV graph means y-axis quantity upon x-axis quantity. On y-axis in IV graph, I is there. On x-axis, V is there. I upon V, there is no direct quantity, but we know that V upon I is equals to R. So by this, can we calculate I upon V? Yes, 1 upon R. It means it will be representing 1 upon R instead of R. So I can write slope of IV graph means uniform slope of IV graph means 1 upon R, 1 upon resistance or reciprocal of the resistance. If you have been asked that whose resistance is more, VI, R1, R2, which resistance is more in a VI graph, then whatever angle is more, whatever angle made from the x-axis is more will be having more slope, right? So can I say slope of second graph? Clearly this angle, the angles are represented by the symbol theta. So theta 2 and theta 1. So R2 is making an angle theta 2 from the positive x-axis. R1 is making an angle theta 1 from x-axis. Clearly slope means angle, whatever angle. So you can write directly theta 2 is greater than to theta 1. Theta 2 will be representing slope of second graph is greater than to slope of first graph. What slope of second graph? VI. Slope of VI graph represent what? Resistance. So R2 is greater than to R1. Clearly we got to know R2 is greater than to R1. That's how the questions can be solved. Did you understand? Yes or no? Tell me quickly.
Yes, sir.
Yes, sir.
Got it? Now, let's discuss another point. If you want to take, you may take the screenshot. I'm going to run it. Sure. So now, if I'll be asking the question, whose resistance is more, R1 and R2, if this is IV graph? So how you will calculate? You know, whatever slope will be there, it is represented by the angle made from positive x-axis. Whatever angle is made, whatever inclined angle will be found by the positive x-axis will be representing the slope. So this angle, which is R2 is making, is called theta 2, and whatever angle is made by R1 is called theta 1. So what I am going to do, clearly, since theta 2 is greater than to theta 1, and I know that that angle always represents the slope. Which slope? But here I is on y-axis, so slope of IV. So slope of IV for second graph is greater than to slope of IV graph of first. Slope of IV represent, we have already taken I upon V, and I upon V is what? 1 upon R. This is for 2, so 1 upon R2. So 1 upon R2 should be greater than to 1 upon R1. But if I'll take the reciprocal, then sign will also change. Just like 1 by 2 is greater than to 1 by 4, but 2 is less than to 4. In the similar manner, 1 upon R2 is greater than to 1 upon R1, then R2 should be less than to R1. It means which one is greater? R1 is greater. So that's how the question can be solved based on this. So did you get it? Yes or no? Quickly tell me. All right, so these are the conceptual questions based on the foundation level, or you can say the little bit up level, which were not basically the slope concept was not included in your course, but still you should know it. Let's begin for let's do something else which is in your course. So since we got to know R is equals to, or by Ohm's law we got to know, whenever you'll be asked, write the Ohm's law means the basic single line statement is equals to V is equals to IR. So by Ohm's law, we get R is equals to V upon I. R is equals to V upon I. And you have been asked, define 1 ohm. Define 1 ohm. And I have already given you the idea that how to define anything related to one, like 1 joule, 1 Newton, 1 coulomb, 1 ampere. So anything, whatever physical quantity to which we need to define as one, first we write the formula or we search the formula. If there is direct formula for the given quantity which we are going to define as one, then we'll be writing it. Otherwise, we'll search that formula in which the quantity which is needed to be defined should come. Got it? So how do I get to know what formula I need to search? We will find it by, or we will understand it by using the unit. So I'll see the unit ohm. Ohm is the unit of resistance. Ohm is the unit of resistance. Resistances are measured in the SI unit ohm. Ohm was the scientist. Based on this, the symbol or SI unit is given to the, or assigned to the resistance. So resistance as the SI unit ohm. So by this unit, I'll get to know that I need to define resistance. So I'll search the formula in which resistance is there. So once I'll search the formula, there is no direct formula, but Ohm's law give me the relationship with respect to R, or with related to R. So since we know that, so this thing you will be writing after here. So question will be asked, define Ohm's law, 1 ohm. Then what you will be writing, since we know that. What do you know that? So many things you know that. But related to here, you know that Ohm's law, we know that by Ohm's law, V is equals to IR, but you need to define R. That's why you need to first make the formula for R. Now, whatever things are given in RHS, substitute all the quantities as 1, 1, 1 with unit. So when V is equals to 1 volt and I is equals to 1 ampere, what do you get? R is equals to 1 volt upon 1 ampere, which is another unit for resistance, whose SI unit is ohm. And 1 upon 1, 1. And since resistance SI unit is ohm, symbol is this, right? Ohm symbol is this one. This one. So I'm writing directly 1 ohm. So how do we define it now? 1 ohm. 1 volt, 1 ampere. What is the basic circuit so that we can think about it? So this is battery. Let's suppose this is the closed switch. Hence and this is plus, this is minus. So the current will always leave from or start from positive terminal, and this is the resistance. The current will flow through this resistance as I, and again enter the negative terminal. Okay. Now V volt battery is applied across this conductor. You can say this is point A. So the same wire is going here. So this is also point A. This is another point B. The same wire is going here. So this point is also E. So in between A and B, if V volt battery is being applied, that means with respect to A and B, that means across the resistance, how much potential or how much battery voltage is being applied? V volt. So whenever V volt battery is being applied, to which I current is passing, so and this is R resistance. So in this formula, how we can define? If V is equals to 1 volt and I is equals to 1 ampere, then R should be 1 ohm. So now we are going to define the definition whenever the 1 volt electric potential or 1 volt potential difference is being applied across a resistor through which 1 ampere current is passed through, then the resistance of the conductor is said to be 1 ohm. When 1 volt of potential difference is being applied across a conductor through which 1 ampere current will be flown, then the resistance of the conductor is said to be 1 volt. So what should be the definition? Hence, when 1 volt of electric potential difference is being applied.
सर आपकी वॉइस क्रैक हो रही
Hello, just 1 second. So hence, when 1 volt of electric potential difference is being applied across the ends of a conductor conductor, just like that. You can also think in such a way. This is nothing but the resistance, right? Conductor is having some kind of resistances, and across its end, that means this is A and this is B. This is the view. If V volt battery means 1 volt battery is applied, due to which how much current is passing through it? 1 ampere. Then whatever resistance it will offer to the current would be 1 ohm. So whenever 1 volt of electric potential is being applied across the ends of a conductor, through which 1 ampere current is passed, then resistance of the conductor is said to be 1 ohm. So said to be 1 ohm. That's how we define the 1 ohm. How many of you got it? Quickly tell me.